This video will go over how to derive the Pythagorean identities, and our first one, to derive that we have to refer back to the unit circle. And so here is a right triangle in the unit circle, where our bottom side is x, this side is y, and our hypotenuse is 1. So we know that sine is opposite hypotenuse, so it's always also seen as a ratio as y over r, and r is always 1, so y over 1, and that is the same thing as y. So we can say that this right here is sine of theta. And the same thing with x. Cosine is adjacent hypotenuse, same thing as x over r, same thing as x over 1, so we can just call it x. And that we can say is cosine. So now that we have this, we can remember that the Pythagorean theorem is a squared plus b squared equals c squared. So if this is like our a and b, and of course the hypotenuse is c, we can substitute and say that sine squared plus cosine squared, equals c squared. And c is 1, so equals 1 squared. And from there we can derive the rest of the identities by, first we do two identities, so it's two steps or equations. So we can set it up. So first we'll start and we can divide everything by sine squared theta. Here they cancel out and we get 1. Here, if we remember the ratio identities, cosine squared theta over sine squared is also cotangent squared. So we can just substitute. And 1 over sine squared, if you remember from the reciprocal identities, is the same thing as cosecant squared theta. So that is our first identity. Looks like this, and there are multiple ways of looking at it. And the second one, instead of dividing by sine squared theta, we divide by cosine squared theta. Again, these cancel. This is also tangent squared theta, so we can just substitute. And 1 over cosine squared theta, that is the same as secant squared theta. We know that because of our reciprocal identities. And this is the third Pythagorean identity.